Hi everyone, let's take a look at the following function. Graph y equal to x squared plus 1 divided by x to the power of 3. Step number 1. Let's write down all the vertical, horizontal, and oblique asymptotes. Now be mindful. One approach is you always want to graph as you go. So for example, if you look at the function, we recognize that the denominator x cubed cannot be 0. This means x cannot be 0. Therefore, there's a vertical asymptote at x equal to 0. If you think about the horizontal asymptote again, by inspection, if you look at the numerator and the denominator has a degree that's larger than the numerator. What that means is there will be a horizontal asymptote at y equal to 0. And again, right now, I'm making the assumption you're taking MHF for you. When you continue with calculus and vectors, we can kind of come back to this and show you why this makes sense using limits. Now, since there's a horizontal asymptote, this guarantees there'll be no oblique asymptotes. So what you have to do now is go back, and I would strongly suggest every student, every person watching this to graph as you go. So what that really means is I go back, and if I grab a different color, I can say here's the horizontal asymptote, here's the vertical asymptote, just like that. Make sure you label them as well. Now, you can always try to find XY intercepts, even though sometimes the answer is none, and that is okay, by the way. So if you want to find the XY intercept, the x-intercept means you set y to be 0. You can equate this to x squared plus 1 divided by x to the power of 3. Or you can simply just focus on the numerator. Now be mindful, if you solve for x here, x squared equals to -1. So technically you could solve for x, but it's going to be a complex root. And the short answer is there are no b roots or no solutions, which means the answer is none. And that is totally okay, the fact that there are no x-intercepts. To find the y-intercept, you're going to set x to be 0. And this is going to be, again, 0 plus 1 divided by 0, which is 1 divided by 0, which is basically undefined. So again, the fact that there are no y-intercepts, that is okay. So next, as you're going back to the graph, you want to find the and behavior. You also want to find the behavior near the vertical asymptote. So for example, if you think about x approaching to 0 from the left or x approaching to 0 from the right, what is happening with y? Well, the choices are either it's going to go up or it's going to go down. And the best approach is you can pick a number a little bit to the left of 0, for example, -0.1. Or when you pick the number to the right, that could be positive 0.1. Now look what happens. In the first case, you're grabbing a number that is less than 0. So if you go back to the function, y equals to -0.1 square plus 1 divided by -0.1 quantity cube. Now the key is you just want to find out, is it going to be a positive number or a negative number? And you can tell in the numerator, that's going to be a positive number, plus 1, that's still going to be a positive number. If you look at the denominator, negative zero point 0.1 to the power of 3 will give you this negative number. So this basically means the graph is going to go down, which means y is approaching to negative infinity. Now, on the other hand, if you think about a number to the right of 0, for example, 0.1, again, you can grab either a calculator or you can do mental math, and you discover this is going to be a positive number, which means y is approaching to infinity or positive infinity, and the arrow goes like that. Now, you also want to think about the AND behavior. As x is approaching to infinity, what happens? As x is approaching to negative infinity, what happens? So it's not enough to say y is approaching to 0. I mean, that's good, but it's not great. If you go back and you pick a number, let's say 1,000, right, and you plug it back to the function, you would discover that you get a number slightly larger than 0. So 0 coming from above, which means it will look something like that. On the other hand, if you plug in x to be negative 1,000, you're going to realize it's going to be coming from below. So again, it's going to look something like that. Last but not least, you can connect them. And of course, if you want to go a little bit beyond this, you want to grab 2 points, no problem, right? This could be, for example, when x equals to 1, you plug it back in. 1 plus 1 divided by 1 is 2. Same idea. If you plug in -1, that's going to be 2 divided by -1. So that's going to be -1, -2. You go back, you label the function just like this, and that's it. Now, if you find this video meaningful, it's adding value to your math life, please comment, like, share, and subscribe. I hope this makes sense.